Hey everybody, I've got 7-1 for you. We are on the 7th section. Yay! 7-1. It's all about the heart. Yay! Yeah, that doesn't look like that. Alright, so this chapter is divided into 3 main sections. 1 is heart anatomy, 2, cardiac muscles, and 3, heart physiology. So we're going to be spending a couple of videos on heart anatomy. I think I should have red ink. That's better for this chapter. Alright, here we go. Oh, it moved. Hold on. It wasn't supposed to be over there. There we go. Okay. Some basic stuff about your heart. There it is. That's your heart. So, some stuff under size, location, and orientation. Alright, it's a little less than a pound, depending on how big you are. In an average human, it's a little less than a pound. In unhealthy individuals, it can definitely be more. It is hollow, meaning there's 4 hollow spaces up inside here, and relatively cone-shaped, kind of like an acorn, if you think about it. Ooh, it's an acorn. Well, now it kind of looks like a ladybug. It is found in the mediastinum, which is that cavity in between your lungs. It rests directly on top of the diaphragm, like that, and about 2/3 of it, oopsie, oh no, hold on. I accidentally touched something again. I need to stop doing that. Go up. There we go. Okay, sorry. And about 2/3 of it end up being to the left-hand side of the midline. If we were to cut you right in half, mid-sagittal, 2/3 of it is on the left side, 1/3 of it on the right side. It's got a couple of features. One is called the base, and it's kind of like this area right here. Now this heart is kind of turned a little for the picture, but usually your heart, this part is kind of even with the diaphragm. So you can imagine your diaphragm is a little flatter than that. We've got the apex, which is the tip of your heart, kind of points down to your left hip. And the base, by the way, if you draw a line, kind of points up to your right shoulder. And then we have something called the point of maximum intensity, or maximal intensity, otherwise known as your PMI. And what that is excuse me, the apex of your heart, when it contracts, kind of slams against the front of your chest wall. And so there's a point kind of on the left-hand side, about 5th rib down, is you can feel, and that's supposed to be the area of greatest contraction. I tried on me. I can't find it, but maybe on a super thin individual we might be able to find it a little bit easier. Alright, some coverings of the heart. So what should we find around the heart? Okay, we've got the pericardium. Okay, the pericardium is just the big bag that goes around the heart. Excuse me, man, allergies or something. And it's made out of 2 layers. So the pericardium, peri means around, cardium means heart. So it's a bag that you cut open on your kitty the other day to expose the heart. And it's made up of a couple of different layers. One is called the fibrous pericardium. So it's a pericardium, but it's fibrous. It's made out of some fibrous connective tissue. It's relatively loose fitting, and it's the more superficial. So if you were to open up your chest cavity, that'd probably be the first thing you saw was the fibrous pericardium. Now I put A here because on the next page there's a picture that has A, B, C, D, and so that's what this goes with. The function of the fibrous pericardium is to protect your heart, helps to anchor it to surrounding structures, like it's continuous with your diaphragm and also continuous with the upper structures of your lungs. And it also prevents your heart from overfilling with blood. Since it is a rigid structure, it can't expand and expand quickly, so it's a nice solid, sturdy bag so your heart doesn't, explode. Okay, the other part is we have the serous pericardium. If you remember way back to Unit 1, we said that there's 2 different types of serous membranes. One that sends directly on the organ and one that surrounds the organ. So if it's right on the organ, we call it visceral, and on top of we call it parietal. So we have the serous pericardium, which is thin and is a little bit deeper than the fibrous. So if I were to cut open the fibrous, the next thing I would see is the serous pericardium. It's thin, it's a little bit slippery because it's serous fluid. It's deep in relationship to the fibrous. It's made out of the 2 layers, parietal layer, which lines the internal surface of the fibrous pericardium. So we got fibrous pericardium. And then we have this layer right here, which would be the parietal pericardium. Okay, and then down here we're going to have the other one, which is going to be the visceral pericardium. That's the outer surface of the heart. So here's the heart itself, and this is sitting directly on the heart. It seems like it is the heart, because kind of it is. And then we have the pericardial cavity in between the parietal and the visceral portions, and that has your serous fluid to help keep your heart nice and lubricated as it beats and pounds inside of the bag. Because the bag sits still, but your heart's inside doing this, and that's a lot of friction. That'd be bad. Okay, that'd be bad. And so you need the serous fluid in there to help prevent that. So if we look at the picture here on the next page, so A, that's your fibrous pericardium. So if you notice, it is continuous with this outer layer here. That's actually the pulmonary trunk right there. So it's kind of one with that. Then we have B, which is the parietal pericardium. And if you notice, it's actually continuous. It goes, does a little U-turn like that. So it's still the same tissue type, but just one's on the outside and one's on the inside. So D, that is your visceral pericardium. And then you've got the parietal space in between here. Now E and F I didn't have on the other slide, but you may figure it out that E is myocardium, which is just the bulk of the heart muscle. And then we have F, which is called the endocardium. And because it's endo, inside the heart. It is also called the endothelial lining, because it's made out of, it's made out of endothelial cells. Here's another picture kind of showing, here's the fibrous, here's the parietal, serous cavity, then we got visceral, myocardium, and then here's the endocardium here. So just two different views to get a same idea of the same thing. Alright, up next, yikes. Dang it, I made this at school, so it didn't transfer over quite nice. Now, problems with the pericardium. Your bag right here is supposed to have a certain amount of fluid in between the heart and the outer bag, but every once in a while we get a buildup of either blood or other fluids in there that you don't want. A lot of times due to bacterial infection, so you have bacteria all over here squirting out all sorts of nasty toxins. And what that does is causes all sorts of fluids to build up. And since, remember, the outer layer is very rigid and very strong, there's nothing to do but push the heart in. And so then your heart can't really beat because it's being squeezed to death, almost literally. So pericarditis, inflammation of the pericardium, and there's not enough serous fluid, so that causes lots of friction. That can cause adhesions, which is when two tissues tend to stick to each other, can reduce heart function. You get lots of extra inflammatory fluids, not the good fluids, the bad ones, and they squeeze the heart. That's called a cardiac tamponade. I think it's kind of funny that all the extra fluid in your heart has the word tampon in it, but hey, whatever. So tamponade, and that just means that you've got extra fluid on the heart. So what do you do to get it out? Oh no! You put a syringe in underneath your sternum, and they go in, and then with an ultrasound, they can feel the pop right here of the fibrous layer, and then they suck out all the fluid. That lets your heart expand, which allows you to put more blood out and makes you feel way better than before. Alright, next one. The heart, oh, that's not going to work. Hang on. There we go. So the heart wall itself is made up of 3 layers. So if I were to take a chunk of heart and slice it and give it to you, you would see 3 distinct layers. You would have the epicardium, epi on top of cardium. So that's the one that sits directly on the heart, otherwise known as the visceral pericardium. And so it's superficial to the heart, has lots of fat in older people. Some of your cats had really fat hearts too. They were probably fed wet food all the time. We have the myocardium, myo meaning muscle. So this is the actual muscle itself and the majority, the bulk of the heart when we think of a heart. And then we have inside cardium. Endocardium, which is a white sheet, and there's that word again, endothelium, of thin connective tissue, which lines the inside of your heart and is continuous with all the blood vessels that go into and out of your heart. A little bit of extra information about the myocardium is that it's composed of cardiac muscle bundles arranged in spirals or circles, and I have a cool picture to show you. And then inside, if we were to dissolve all the muscle cells, you would be it's a wasp. You'd be left with the fibrous skeleton of the heart. And what that is a whole bunch of dense connective tissue fibers that basically act as a scaffolding for your heart, so that way the muscle cells have something to attach to, because they don't have any bones to attach to, so they need something a little bit thicker. So here's a picture kind of explaining that. So if you notice how the heart, the muscles, these are the circular ones, and then these are the spiral ones. It kind of looks like a Mobius strip to me, like that, does a little figure eight. Here's the skeleton of the heart, including the fibrous rings around the valves. So we see we have a lot of cartilage-like structures in the arteries, and then inside of the heart, it's all over the place down in here, and that's what the muscles are hanging on to. Okay, next one, chambers of the heart. We are almost done. There we go. So we have the atria, which are the upper chambers of the heart. If we say one of them, it's atrium. More than one is atria. We have the ventricles, which are the two on the bottom, and they're the pumping guys. And then separating them, if this is a very basic heart, so we've got the atria and the ventricles. So right here, this one right here, that's the interatrial septum. Septum means a divider. So an interatrial septum is the thing that divides the left and right atrium. There's also a ventricular one right here. That's the interventricular septum, divides the two ventricles. Now on the heart, when you look at the heart, there's grooves, so it's not completely smooth. There's dips in there. Those dips or grooves show where things come together on the inside of the heart. So the atrioventricular groove, as you can imagine, if this is my heart, it's a groove that goes around like this, also called the coronary sulcus, because coronary means crown, and if you kind of think about it, this looks like a crown around the outside of the heart. So that just separates the atria from the ventricles. And then we have the, I'm sorry, this part, the coronary artery sits in it, so you'll see it on the outside of a heart. Then we have the anterior ventricular, these are hard to say, anterior interventricular sulcus. So once again, here's my heart. And so anterior means facing front, and this one separates the left and right ventricles. So here's the one from before. So here's a little one kind of like this. Now there's one main one on the front that separates the left and the right ventricles, and the anterior interventricular artery sits in it. And then on the back side, if I turn him around, there's another one kind of following that same pattern, kind of scooping up the back, and that's the posterior, because posterior means in the back. Okay, so here's some pictures to show this to you. Sorry, the words didn't come out too nice. So here's the coronary sulcus. So it's a groove that kind of walks around like this. The coronary, meaning, crown. And so you can see a lot of fat buildup in there, and it separates the atria from the ventricles. Okay, let's see, over here, kind of goes like this, and around like that. It's not a nice straight line. The other one, we've got the anterior interventricular sulcus, just goes right down the middle like that. And it's easy to find, just follow this little artery. And then on the back of the heart, there's going to be another one going up the back as well. So sulcus just is a fancy word for groove or dip. Okay, so, oh great, I can hear my kid crying. Nice.
Everything's just fine. Emily's kind of okay.
She's kind of okay?
Yeah.
She fall down?
Yeah.
Does Dad got her?
I'm gonna go get an ice pack.
Does Dad got her?
Yes.
Okay, I'm all good then. Okay, so the right atrium, this guy right here, gets blood from 3 different locations. 2 of them are quite obvious. It's the vena cava. So you have your superior vena cava and your inferior vena cava, and they dump out little holes inside of here. But the one you're probably not too familiar with, or you usually don't see on these diagrams, is the coronary sinus, and that's from the heart itself. So the heart is a muscle, and it needs food, and so it dumps, has a little hole back here that it dumps its blood into as well. Superior takes care of the head and the arms, and the inferior takes care of legs and trunk. Basically, the diaphragm is the divider between superior and inferior. And then the left atrium over here, he's going to get blood from, actually, whoopsie, that should be 4, from 4 pulmonary veins. There's two, let's see, there's two on the left-hand side and two on the right-hand side. And those four altogether carry blood from the lungs into the left atrium. I always have to turn myself around because you're looking at the heart as if it's facing you. Okay, let's see. And the atria, the receiving chambers, let me scoot this out of the way. Oops, gosh, dang it. I got this. Okay, so the atria, those are the top portions. They have what are called auricles, which actually means ear. And so they look like little wrinkly ears hanging out from the outside of the heart. And, God, there's wasps everywhere. Inside, they have a very smooth posterior wall. So if you open a atria, in the back, nice and smooth. But on the on the inside anterior, facing outwards, is ridged with pectinate muscles. So they're just muscles that kind of look like that. There's something called the cristae or cristae terminalis, which is a C-shaped ring that separates the anterior and posterior regions. So if this is the auricle or the atria, there's a little ring, a C-shaped ring, kind of like that inside. And you'll also find something called the fossa ovalis. If here's the other atrium right here, there's a little depression right about there. And fossa means hole, ovalis, oval, oval hole. And what it is, it's a little depression in the septum, shows where the foramen ovale, which is a big open hole, existed in the fetal heart. Because remember, you didn't use your lungs as a fetus, the blood went straight from one atria to another. And so there was a hole right here, and then when you're born, within the first few seconds, the sucker closes up nice and tight. If it doesn't, then they got to go and surgically and repair it. Atria are typically pretty small because they only need to shove blood that far, not very far at all. Whereas the ventricles, oh, sorry, here's some little guys for you. So here is an atrium right there. And the other one's actually hiding back here. It's really hard to see. And then let's see, here's one dangling like that. And here's another one dangling like that. So they're really small. Usually when you see hearts, you would think that they're all even, but they're not. They're really tiny and dinky. Alright, and then the last part. Oh, wait for it. Sorry, I'm looking at the time. I know. I'm sorry. Okay, so we have the ventricles, which are the bottom chambers. And the right ventricle is mostly face forward. The left ventricle is mostly face back. And inside, if you open up the heart, you're going to find these things called trabeculae carnii. Meat bridges is what this means. Remember trabeculae and bones? Carne asada, meat bridges. So these are irregular muscle layers that are found inside of the heart. We also have these things called papillary muscles, which are, remember papillary? Nipple-shaped. So these are little muscles that are, hey, look at that, nipple-shaped. Cone-shaped muscles that attach to valves. And then the right ventricle will pump blood to the pulmonary trunk and then to the lungs, so that it's a little bit smaller because it only has to go that far, whereas the left ventricle has to pump to the aorta to the rest of the body, so it's really super thick because it's got to pump all the way up to here and all the way down to your toes. So here are some lovely pictures showing that. Let me scoot him over again because he's kind of in the way. And you scoot over. Okay, so we've got the... here's those funky muscles we're talking about, the meat bridges, trabeculae carnii, and then let's see, here's a little papilla. There's another one right there. You can see them in here. Oh, there's a big one right there. But you see this kind of fibrous network? That's all the trabeculae. Here's a nice up close one of a papilla, and then plus some fibers hanging off of it. Alright, that's it. I apologize, the sucker was 20 minutes long, but that's okay. I love you. Bye-bye.